Welcome to Autotech Labs. Let's see how a car engine cooling system works. A car engine is basically an internal combustion engine where power is generated through expansion of high temperature and high pressure gases. A lot of heat is generated due to the combustion gas and the friction of mechanical parts. For sustained operation, these excess heat should be removed from the engine and kept at operating temperature. Now let's see the parts involved in cooling the engine. The main parts for cooling the engine are water pump, radiator, thermostat, coolant temperature sensor, and coolant. First, the water pump. Water pump is the heart of the cooling system, which pumps the coolant. It consists of an impeller, a pulley flange, and an O-ring. The impeller is driven by the engine drive belt through a pulley. Next, the radiator. The radiator is a heat exchanger used to transfer the excess heat developed by engine to the atmosphere. The radiator is having an inlet port, outlet port, a drain plug, and a radiator pressure cap. The radiator pressure cap plays a vital role in the cooling system, which will be explained later. Next, the thermostat. The thermostat is a valve which regulates the flow of the coolant and helps to maintain the proper operating temperature for the engine. The thermostat consists of a frame, charge cylinder, main valve, main spring, bypass valve, and secondary spring. Next, the coolant temperature sensor. The coolant temperature sensor is used to monitor the engine temperature. The ECU will use this data to manage fuel injection and ignition time. Some engines have more than one coolant temperature sensor. The data is also used to control the radiator fan and to update the temperature gauge on the driver console. The coolant temperature sensor consists of a sensing probe and an electrical connector. Most coolant temperature sensors are negative temperature coefficient type, which means as the temperature increases, the resistance will decrease. The CTS can be a 2-pin type, or a 3-pin type, depending on the make of the vehicle. These are the main parts involved in an engine cooling system. Now, let's see how these parts works together. The pistons are contained inside the engine block, in which each of them will function. Above the engine block comes the head gasket, which provides sealing between engine block and engine head. It avoids compression leaks and oil or coolant leaks into the cylinders. Above that comes the engine head. The engine is having a safe passage through which the coolant can flow without entering into the cylinder or mixing up with the oil. This passage is known as water jacket. Let's put the parts one by one and see how it works. The water pump pumps the coolant throughout the system with the help of the radial impeller. It is driven by the engine itself, using a serpentine belt. The serpentine belt also drives the power steering pump, alternator, AC compressor. But for now only water pump is shown. Now let's see the connections. The thermostat bypass hose. The thermostat housing. Inside the thermostat, the radiator, and the radiator fan. The lower radiator hose. The water pump outlet hose. The upper radiator hose. The coolant expansion tank. The expansion bleed hose. Coolant overflow hose. So, finally, let's get into the working, starting with the thermostat. The thermostat is actually a valve, which regulates the flow of the coolant. It will always be covered in the coolant, so that the temperature can be sensed. Let's start the operation from a cold engine. When the engine is cold, the bypass valve stays open. So, the coolant bypasses the radiator and recirculates through the engine. This helps the engine to heat up to operating temperature quickly. Eventually, the coolant temperature increases by absorbing the heat from the engine. Once the coolant starts to reach higher temperature, which is usually between 160 to 190 Fahrenheit, the bypass valve will start to close, and the main valve will start to open. This allows the cold coolant from radiator flow to the engine side, and the hot coolant from engine side flow to the radiator. In most cars, the coolant temperature sensor is located near the thermostat housing. It will turn on the radiator fan if the coolant to the radiator side is at high temperature. Now, the hot coolant in the radiator will release its heat to the atmosphere with the help of the fan. At the same time, the cold coolant received from the radiator will start to absorb the heat from the engine for the next cycle. Heating liquid inside a closed system always builds up pressure. So, how to maintain the pressure? Here comes the role of the radiator pressure cap. It consists of a spring-loaded valve mechanism, which will respond to higher pressure. Reaching a pressure above 15 psi will push the pressure cap valve, and the coolant flows to the expansion tank, until the pressure goes down to operation level. And when the system cools down, the vacuum inside the system sucks back the coolant from expansion tank. In case if there is too much pressure build-up in the system, due to trapped air, or other failures, the coolant in the expansion tank will be pushed out through the overflow hose. The car heater system is a part of the engine cooling system. The heater system comprises of the heater core, inlet and outlet hoses, a heater control valve which is optional and cannot be found in all vehicles. The heater core acts as a radiator, dissipating heat from the hot coolant to the vehicle interior, using a blower.